Welcome to this tutorial. In this tutorial, I'm solving question number 1 of paper 2-1 of October-November exam series of 2021. The question says figure 1.1 shows a wooden bench of weight 2000 Newton. So there is a bench given in the question and the weight of the bench is 2000 Newton. Now the bench has some dimensions given to us also, and the length of the bench is given to be 2.2 meters here, and the width of the bench is given to be 0.48 meters. Each of the two supports that has an area of 0.040 meters square in contact with the ground. Calculate the pressure on the ground due to bench. So this bench is in contact with the ground with the help of these two supports. One is here and the other one is here, and we have to calculate the pressure exerted by the bench on the ground. So we know that the formula of pressure is normal force per unit area. The force would be equal to the weight of the bench, which is 2000 Newton, and the area would be twice the area of one support. So I'm multiplying the area, the given area 0.040 with 2. So it becomes 1000 divided by 0.040, and the answer we get is 25,000 pascals. So this is the answer for this part, 25,000 pascals. Next part says the center of mass of the bench is 1.1 meter from the left hand end of the bench and 0.24 meters from the front. Okay, so now we are given with the center of mass. So the question says it is at a point which is equal to 1.1 meter from the left hand end, and similarly it is 0.24 meters from the front. So this becomes the mid of the table where the center of mass of the table lies. Suggest one reason why the center of mass is in this position. So the reason we can state is the bench is symmetrical left to right and front to back. So center of mass is in the middle. So as we have seen in the figure, the bench is symmetrical, so it would be half at a half distance or in the middle from the lengthwise and the widthwise of the bench. The next part says there is a force exerted vertically downwards from the point P as shown in the figure 1.1. Calculate the maximum force that can be exerted vertically downwards at P without the bench rotating about the point Q shown in the figure. We are exerting a force on this point P, and this line becomes the pivot. This line would become the pivot for us. So due to this force, the bench is supposed to rotate in the anti-clockwise direction. Similarly, the center of mass at the center of mass of the bench, the weight of the bench would act downward. So we would experience a clockwise moment because of this force. The bench has to remain in equilibrium. So both these moments are going to be equal. So from the line of rotation or the point of rotation, the distance of force P is 0.25 meters. So the distance would be this much from this point to the line of action of force of weight of the bench. And this could be calculated when we subtract 0.25 from 1.1. So it would give us 0.85 meters. So we are going to use these values. The value of weight is 2000 Newton and its distance is 0.85 meters. Then there is a force of P creating an anti-clockwise moment at a distance of 0.25 from the pivot. So first I'm writing the principle of moments here, that clockwise moment should be equal to anti-clockwise moment. So for clockwise moment, we have a force of weight acting at a distance of 0.85. For anti-clockwise moment, we have a force of P acting at a distance of 0.25. So P is going to be equal to 2000 multiplied by 0.85 divided by 0.25. So it will give us an answer of 6800 newtons, and this would be the final answer of this part. So the question ends here with this answer. Welcome to this tutorial. I'm solving question number 2 of paper 2-1 October-November exam series of 2021. The question says figure 2.1 shows a man of mass 80 kilograms standing in a lift elevator. The gravitational field strength G is 10 Newton per kilogram. Calculate the weight of the man. So for weight we have the formula W is equal to mg. The mass of the man is given to us as 80 kilograms. The value of G is 10. So the weight of the man is going to be 800 newtons here. So this is the answer. Next part says the lift accelerates upwards uniformly at 0.50 meter per second square. So we are given with the value of acceleration here. Calculate the resultant upward force on the man. So the resultant upward force would be mass times this acceleration. Mass of the man is 80 multiplied by the acceleration. So the resultant force we get for this part is 40 newtons. The next part says the force exerted on the man by the floor of the lift. So the floor of the lift would be exerting two forces, one equal to the weight of the man to lift him, and the other force would be the 40 Newton force to create that acceleration of 0.50 meter per second square. So the total force exerted would be the sum of these two forces. The last part says the lift accelerates upwards uniformly from rest for 4.0 seconds, then decelerates uniformly to rest in 4 seconds. So we have two parts here. For the first 4 seconds, there is an acceleration and there is a uniform acceleration. And after 4 seconds, there is a deceleration till the lift comes to rest. The total distance traveled is 8 meters. On figure 2.2, sketch the distance time graph for this journey. So the first part of the journey starts from origin and there is an acceleration till 4 seconds. So a graph would be made like this on distance time graph. Because it is accelerating, so the gradient is not going to be constant here. We would be showing it using a curve over here. Then we have to show a deceleration. Now for the second part of the graph would tilt or bend towards the time axis and it would become perfectly horizontal at time 8 seconds. So this first part shows the acceleration when the curve is taking a bending towards the distance axis. So means speed is increasing, there is acceleration. And when the graph is bending towards the time axis and becoming horizontal slowly, it means that it is decelerating and coming to rest. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 3 of paper 2-1 October-November exam series of 2021. The question says a type of nuclear reaction that takes place at the center of the sun. The reaction releases thermal energy. State the name of the type of nuclear reaction that takes place at the center of the sun. So at the center of the sun, we know that the reaction that is taking place is nuclear fusion. Thermal energy is emitted from the surface of the sun into space. The energy is transferred through the vacuum of space by thermal radiation. Describe the radiation that is emitted from the surface of the sun. So the energy or the radiation emitted are the radiations are electromagnetic waves. These are infrared radiations which are produced by hot objects. Okay, the next part says state the speed of the radiation in the vacuum. So in a vacuum, the speed of electromagnetic waves is 3.0 10 raised to 8 meters per second. The Earth is at 1.5 10 raised to 11 meters from the surface of the sun. So the distance is given to us. Calculate the time taken. We have to find the time taken for the radiation to travel to Earth. So for this, we are going to use the formula distance is equal to speed multiplied by time. So it means time is equal to distance divided by the speed. The value of distance is given to us, and the value of speed we already know in the vacuum. So the answer we get is 500 seconds for this part. Explain one advantage of wearing white clothes on sunny days. So white clothes are especially helpful for a sunny day because white surfaces are good reflectors and they do not absorb heat energy much. So less thermal energy is absorbed. That is why it is good to wear white clothes in sunny days to avoid the absorption of heat in the clothes. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 4 of paper 2-1 October-November exam series of 2021. The question says, in a coal-fired power station, coal is burnt and electrical energy is produced. State the form of energy in the coal that is transferred to electrical energy. So all the fuels, they contain chemical energy, and this is converted into other forms. Part B says, state the principle of conservation of energy. So the principle says energy can neither be created nor be destroyed, but it can be transferred from one form to another. The next part says the quantity of electrical energy produced by the power station is much less than the quantity of energy in the coal that is burned to generate the electricity. Explain why this is so. So the reason for this is that some of the chemical energy is transferred to thermal energy, and this thermal energy is lost to the surroundings. So it is wasted and not converted into electrical energy. The last part says state one environmental consequence of generating electricity in coal-fired power station. So one environmental consequence could be global warming because of the production of carbon dioxide gas, carbon monoxide gases, and the greenhouse effects that takes place because of them. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 5 of paper 2-1 October-November exam series of 2021. The question is related to the electrostatic charges. The question says a plastic rod that is initially neutral is rubbed with a woolen cloth. After the rod has been rubbed, it is positively charged. Explain in terms of particles why the rod is now charged. So the reason is that the positive charge is created because the electrons have been transferred from the rod to the cloth. So we would say the electrons are transferred from rod onto cloth. So that is why the lack of electrons has created a positive charge. State what happens to the woolen cloth. It becomes negatively charged, or the surface becomes negatively charged because of having excess electrons. An uncharged conducting sphere is suspended from an insulating thread. The positively charged rod is placed near the sphere as shown in the figure. On figure 5.1, draw the distribution of charge on the sphere. So for the distribution of charges, we know that it has positive charges, and the negative charges are also distributed accordingly on the sphere. But when the positively charged rod is brought near the sphere, there is a buildup of negative charge on the side from which the rod is nearer. So this side of the sphere builds up more negative charges as compared to positive charges, and this side of sphere has a deficiency of electrons, so a positive charge dominates here. The next part says explain why the sphere is pulled towards the rod. So the reason is because of electrostatic charges. We have negative charges of the sphere are attracted by positive charges of the rod, and distance between negative on the sphere and positive charges on the rod less than the distance between positive on the rod and positive on the sphere. So that is why the repulsive forces are not that stronger the way the attractive forces are. So that is why the sphere is attracted towards the rod. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 6 of paper 2-1 October-November exam series of 2021. The topic of this question is current electricity. The question says a circuit contains a battery of electromotive force EMF 4.5 volts, a 20 ohms resistor. So we have an EMF source where more than one cells are connected and a 28 ohms resistor and a variable resistor whose resistor could be varied. Figure 6.1 is the circuit diagram. The battery consists of 3 identical cells in series. Determine the EMF of each cell. So it means that there should be at least 3 cells and each of them should be of 1.5 volts. That is why the total EMF is 4.5 volts. So 4.5 divided by 3 is 1.5 volts. This is the EMF of each individual cell. The next part says the potential difference across the variable resistor is 2.5 volts. State what is meant by the potential difference. So potential difference could be defined as the energy transferred when charge passes through a component. So we also have to write the formula. The formula for finding the potential difference could be work done upon charge or energy upon charge. So this would be sufficient for a 2-mark question. Now the next part says calculate the resistance of the variable resistor. Now we know that the potential difference across the variable resistor is 2.5 volts. So using this we can find out the resistance value. First we find the voltage across fixed resistor. So it would be 4.5 minus 2.5. It would have a voltage of 2.0 volts across it. So the current through the fixed resistor would be 2.0 divided by the value of its resistance, and it is given to us as 28. So the current is 0.07 amperes. Now the resistance of the variable resistor would be its voltage divided by the value of current. So the voltage is 2.5 and the value of current is 0.07. So the answer comes out to be 35 ohms. So the answer for this part is 35 ohms. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 7 of paper 2-1 October-November exam series of 2021. There are two parts in this question where we are given with a choice. So I'm solving the first one here. It says figure 7.1 shows a solenoid connected to an ammeter. So we have a solenoid over here, the coil. Then we have an ammeter connected across it. So it would detect the current if there is any current in the coil. And then we have a permanent magnet which is moving towards the coil. The S pole of a permanent magnet moves into the left-hand end of the solenoid. The ammeter reading shows that there is a small positive current in the circuit. Explain why there is a current in the circuit when the magnet moves. So the reason is because of the movement of the magnet, magnetic field lines cut the coil. So there is a changing magnetic field in solenoid. So when there is a changing magnetic field across a conductor, we know that an EMF is induced in the conductor. And because of this EMF, the current flows. So I'm writing which produces the current, and because of this current, there is a reading on the ammeter. The next part says when the magnet is inside the solenoid, it stops moving. It is then pulled back out of the solenoid. Explain what happens to the ammeter reading as the magnet moves out of the left-hand end of the solenoid. So we have negative reading of current because initially when the magnet was moving towards the coil, we had the positive reading of the current, and now we would have the negative reading of the current because, and the reason for this is the magnetic field lines are cut in opposite direction as compared to the one that was being done before. So when the cutting takes place in the opposite direction, the opposite EMF or the EMF with opposite polarities is induced, and because of this EMF, opposite current or the reverse current or negative current flows through the coil. I would be solving question number 7, which has a choice. So I'm solving the second part, which is related to the logic gates. It says figure 7.2 shows the symbol for a logic gate and its truth table. So we have a symbol over here, and it is an OR gate which has an inverter applied to its output. So when the both inputs are 0, the output becomes 1. Otherwise, the output remains 0 when either one of the input is at logic level 1 or both are at logic level 1. So simply they are being ORed first. So we have this output when we apply the OR gate to the inputs, and then we apply an inverter. So every output is inverted. 0 becomes 1 and 1 becomes 0. Now the question says state the name of this logic gate. So it is a NOR gate, an inverter applied to an OR gate. Figure 7.3 shows two of these logic gates connected to make a bistable circuit. So we have a NOR gate over here where a P input is being applied. Similarly, a Q input is being applied to the second NOR gate. The output of this first NOR gate is again input at the second NOR gate, and the output of the second NOR gate is again input to the first one. The output of the first is called X, which becomes an input for the second one. The output for the second becomes Y, and it becomes an input for the first one or the upper one. Terminals P and Q each have logic level 0. So we have a logic level 0 here and here. Terminal X has the logic level 1. So we have 1 over here. Explain why the terminal Y has the logic level 0. So it is 0 because when Y becomes 0 and it becomes an input to the upper NOR gate, the output would become 1. And if it is not 0, for example, it is at 1, then this would also be 1, and 0 and 1 would give us the output as 0. So it cannot be 1 unless the y is at 0. So both the inputs for the upper NOR gate become 0 and the output becomes 1. So now we have to explain. I'm writing y is an input to the upper NOR gate and it has to be a 0 for the output to become 1. So since the output of the upper NOR gate is 1, the other input also has to be 0. The next part says terminal P is briefly connected to a supply of logic level 1. State the effect of this on the logic level of terminal X and the logic level of terminal Y. So now the terminal P is briefly connected to 1. So I'm changing it and this terminal becomes 1. Now when this becomes 1, the X would become 0. So this 0 would become the input for the lower NOR gate, and when both the inputs are 0, the output of the lower gate would change into a 1. So I'm writing the answer here that X changes to 0 and Y changes to 1 because of this change. The next part says terminal P returns to logic level 0 again. State the effect of this return to 0 on the logic level of terminal X and on the logic level of Y. Now for this part, P again changes to 0. So we have a 0 here at terminal P. Now the other input received by the P has now changed to 1. So there are two inputs because this output changed to 1. So this would become the input for the NOR gate. And when 0 and 1 are applied at the input, we have the output still equal to 0. Now this 0 would be applied over here. So both the inputs for the lower NOR gate are 0 and the output would remain 1. So it means that there is no change taking place for the X and Y when P is changed to 0. So I'm writing the answer. Both stay the same and do not change. So the next part says state how the circuit exhibits the property of memory. So the circuit shows that the output shows which terminal last had the value 1. So this is how it exhibits the property of the memory. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 8 of paper 2-1 October-November exam series of 2021. The question says a loudspeaker is made from a coil of wire fixed to a cardboard tube. The tube is attached to a cardboard cone. Figure 8.1 shows parts of the arrangement of the loudspeaker. When there is a current in the coil experiences a force. State what else is needed in a loudspeaker to make a current carrying wire experience a force. So a force is experienced when a current carrying wire or conductor is placed in a magnetic field. So a magnet or magnetic field is required here for this current carrying wire to experience a force. The next part says a student connects the coil to the output of an alternating current or AC generator. Figure 8.2 shows how the EMF produced by the generator varies with time. So this EMF is showing that we have an alternating EMF applied to the coil, and one cycle is completed for this signal in 0.005 seconds. The coil, tube and cone vibrate backwards and forwards. Explain why the EMF shown in figure 8.2 makes the coil vibrate. So the EMF shown is telling us there is a positive half cycle and then there is a negative half cycle in the EMF signal. So when the positive half cycle of the EMF is there, there is a flow of positive current, and when the EMF changes its direction to the negative half cycle, there is a negative current flowing. So when the current continuously switches its direction, the force being exerted on the coil placed in a magnetic field also changes. So the answer would be the current in the coil continuously reverses direction, and the force on the coil continually reverses. So when there is a force in one direction, it might move forward. When there is a force in the opposite direction, it might move backwards. That is why this whole arrangement is moving or vibrating backwards and forward. The next part says the vibrating cone produces sound in the air. Explain in terms of molecules how the cone produces a sound wave that travels through the air. So when the cone moves forward, air is compressed, and when it moves backwards, air a rarefaction is produced. So we have continuous production of compression and rarefaction. So production of compressions and rarefactions continues. That is why there is sound produced in the surrounding. Sound is a longitudinal wave. Describe the difference between a longitudinal wave and a transverse wave. So in a longitudinal wave, particles of the medium vibrate parallel to the direction of propagation of wave, while in transverse they are vibrating perpendicular. So in a transverse wave, particles vibrate perpendicular to the direction of propagation of wave, and in longitudinal, they are parallel. Using figure 8.2, determine the number of times that the cone reverses its direction of motion in 1 seconds. So we can see that one wave is completed in 0.05 seconds. So it means the time period of the wave given is 0.05 seconds. Now we can use this to find the frequency. So when 1 divided by 0.005, so the frequency comes out to be 200 hertz. So in these, so 200 hertz tells that there are 200 waves in 1 second, and each wave has a positive cycle and a negative cycle inbuilt. So it means that the direction of the wave is changing twice the number which is showing us the frequency. So it is 400 times per second where the direction of motion is changing. Now the next part says the speed of sound in air is 340 meters per second. We are given with the value of the speed. We have to calculate the wavelength of the sound. So V is equal to F lambda is the formula which would be used here, and lambda, the wavelength, would be equal to speed divided by the frequency. Speed is 340 and the frequency is 200. So the answer we get is 1.7 meters. The wavelength of the sound here is 1.7 meters. The next part says the student adjusts the generator so that the maximum voltage of the output is now 3 volts. Everything else remains the same as the output shown on the figure 8.2. Explain any effect on the loudness of the sound. Now, since the maximum voltage is decreasing, before it was greater than 3 volts and now it has been reduced to 3 volts, so the new pattern for the wave would be like this. So we have a wave whose amplitude is 3 volts now, and the amplitude has decreased a little. So the decrement in the amplitude shows that there is decrease in the energy, and when there is decrease in the energy, the loudness decreases. So we would say that loudness decreases because loudness is proportional to amplitude, and when the amplitude decreases, the loudness decreases because the maximum force on the coil decreases. So because of the decrease in the value of the EMF, the current is going to decrease, and the force which it was previously experiencing would also decrease, and that would decrease the loudness of the sound. Explain any effect on the pitch of the sound. So there is no effect because frequency is not changing. So we would say that pitch remains the same because pitch depends on the frequency of the signal. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 9 of paper 2-1 October-November exam series of 2021. The question is related to thermal physics. It says liquid and glass thermometers use the expansion of a liquid to indicate the temperature. Figure 9.1 shows the molecular structure of a solid. Here is the structure of the solid and a gas. In the middle box of figure 9.1, sketch a diagram to show the molecular structure of a liquid. So this is how we can show the structure of a liquid. Explain why it is easier to compress a gas than to compress a solid. So the reason is that molecules of the gases are further apart and they could be brought closer to each other because they have weaker repulsive forces amongst them. So that is why they can be compressed and brought closer to each other. The temperature of a liquid in glass thermometer increases. State 2 ways in which the molecules of the liquid in the thermometer are affected. So when the temperature is increased, they start moving faster and they move further apart because of the thermal expansion. So that is why we have a larger reading in the thermometer. The next part says figure 9.2 shows the liquid in glass thermometer. We have a bulb, liquid, and then we have a narrow tube here. There is no scale on the thermometer. State what is meant by the ice point and the steam point. So ice point is defined as the temperature where ice and water are in equilibrium. Or it is the melting point of water. Now the steam point is defined as the temperature where water and steam are in equilibrium, or it is also called the boiling point of water. The next part says describe how the ice point and steam points are used on the thermometer. A 0 degree centigrade is marked at ice point, the level of liquid which is shown when the thermometer is dipped into a mixture of ice and water that is going through melting, and 100 degree centigrade is marked at steam point when the water has started to boil. So the level of liquid shows us where the 100 degree centigrade should be marked. And the interval is divided into 100 divisions. So this is how the scaling on a thermometer is done. The next part says explain how the range of a liquid in glass thermometer is affected by increasing the mass of liquid in a bulb. So when we increase the mass, the range decreases because a greater mass shows more expansion. So when the expansions are larger, the range decreases. Increasing the diameter of the narrow tube. So when we increase the diameter of the narrow tube, the range increases. Because a range is proportional to square of the diameter. So by increasing the diameter, we are increasing the range, and hence greater temperatures, greater temperature increase is needed for greater volume increase. So the question ends here with this part. Welcome to this tutorial. I'm solving question number 10 of paper 2-1 October-November exam series of 2021 in this tutorial. The topic of this question is half-life. The question says the isotope yttrium-90 Y9039 is radioactive. It is a beta particle emitter. So it is a very important information about the radioactive substance that decays to product Q. The product Q is stable. Part A state one feature that is common to all isotopes of yttrium. So the common feature could be stated as they have same number of protons. All the isotopes of an element have same number of protons. Describe how a neutral atom of Q differs from a neutral atom of yttrium. Since product Q is being formed when yttrium is undergoing a beta decay, so let me write the equation first. We are starting with yttrium 3990. When it undergoes a beta decay, it emits a beta particle whose charge number is -1 and mass is 0, and a product Q is formed. Now in a beta decay, we know that a neutron from the yttrium would be converting itself into a proton and an electron. This electron would be emitted from the nucleus, but the proton remains a part of the nucleus. So as a result, the proton number increases by 1, but the nucleon number remains the same. Although the nucleon number remains the same, but the composition here is different. For Y or yttrium, we have 39 protons and 51 neutrons here. while for Q we have 40 protons and 50 neutrons. So using all this information, we can write the answer for this part. So we have to describe how a neutral atom of Q differs from a neutral atom of yttrium-90. So it has, the first thing is it has one more proton and one more electron as compared to yttrium, while Q has one fewer neutron as compared to yttrium. So the number of protons for Q are 40, one is greater than yttrium, and the number of neutron is 50, one fewer than of yttrium. And the number of protons, electrons are same for a neutral atom. So the number of electrons are going to be equal to the number of proton in a neutral atom of Q. Next part says a sample of yttrium is placed close to a radiation detector in a laboratory. There are no other radioactive samples in the laboratory. A counter records the count rate. Figure 10.1 is a graph of the count rate plotted against time. So we have the count rate, counts per minute here on the y-axis, and we have time in hours on the x-axis. So from this figure, the first task is we have to use this figure to determine the average background count rate. Now from this figure, we can see that the count rate is starting at a value of 70, 72, 74. So it is starting around 74 and then it is decreasing. But we can see after reaching a certain value here, the count rate is not decreasing further. It has become constant. So if we take this value, it becomes equal to 18 on the y-axis. So the background count rate is the value obtained from the half-life curve. It is the value after which the curve does not decrease further. So when the exponential decay of the curve stops and the curve becomes constant or horizontal, that gives us the background count rate. So from this graph, we can say that average background count rate is 18 counts per minute. Now the next part says suggest two different origins for the background count rate. So one could be rocks. They contain the radioactive material, so they emit radiations. And secondly, we could say that cosmic rays could be another source of background count. Using figure 10.1, determine the half-life of yttrium-90. Show how the answer is obtained. So from that graph, we have to find the half-life. We can see that the initial value for the count rate is 74. We have already found the background count rate, which was 18. So I'm writing here first the initial count rate would be equal to, when we subtract the average background radiation, it is 56 counts per minute. Okay. Now the next thing is we know that after one half-life, the count rate is going to decrease by half. So after first half-life, it would become 28. While on the graph, since the average value of background count rate would be added to this value, so on the graph it would be equal to 46 counts per minute. Okay. After the second half-life, the 28 would again be halved and it would become equal to 14. While on the graph, the value taken should be 14 plus the average background count rate. So it would be equal to 32 counts per minute. Now, continuing in the same manner, the next point is when we have after third half-life, the count rate would further decrease by half and it would become 7. And on the graph, we have the value of 7 plus 18 equal to 25 counts per minute. So this is the third value that we have obtained here. The first one is the initial one here. After first half-life, it becomes 46 on the graph. After second half-life, it becomes 32. After third half-life, it becomes 25. Now, we would consider these points on the graph and find out what is the value of time in hours against these count rates. So the first one is 46, and 46 is indicated by this line. This is the 46. And if I match this line horizontally with the curve and then I bring it down to the x-axis, the value obtained is 50, then 60, and a little before the mid. So it could be taken as 64. So this is the first value obtained against the value of 46 after first half-life. The next point is 32, and 32 is being shown by this box. So I make a horizontal line here, and then when I match this line with the horizontal axis, the value we get is exactly 130 hours. Okay, so the next point, 46, 32, the next point is 25, and 25 is in the mid of 20 and 30, so it is here. So when I match this point with the curve, we get a value which is in the mid of 190 and 200. So it is almost a value of 195. So these are the three values that we are getting: 64, 130, and 195. So I've written all the points here which we found from the curve. And now we would use these points in the form of pairs to find the half-life here. So the first half-life we can calculate here by subtracting the value of time. So 64 minus 0 gives us a half-life of 64. Then if we use the second and the third point, the value of half-life we get is 130 minus 64, 66 over here. And now I would be using third and the fourth point as a pair. So the value of half-life we get is equal to 195 minus 130, and it is equal to 65. Now to find out the final value of the half-life, we are going to average out these three values, and by adding them and then dividing by 3, we get a value of 65 as their average value. So the final answer for this part would be the half-life is 65 hours. So this is the procedure to calculate the half-life using the given graph. The next part says many of the points plotted in figure 10.1 do not lie on the best fit line. Explain why. The reason is that the radioactive decay is random in time, which means it is impossible to predict when a beta particle would be emitted. So there is no pattern in this emission. It is unpredictable. That is why the points sometimes lie above the best fit curve or the line, and sometimes they lie below the line. Okay, the last part of the question says a beam of beta particle traveling in a vacuum enters a region between two plates. One of the plates we can see is a positive charge carrier and the other plate has a negative charge. One plate is negatively charged and the other is positively charged. Figure 10.2 shows the arrangement. On figure 10.2, draw the path taken by the beta particles as they travel between the plates. So when the beta particles would enter the plate, they would make a curve like this, and they would be bended towards the positive plate. Since they carry negative charge and negative is repelled by the negative plate and attracted by the positive plate, so they would be attracted towards the positive plate. So the question ends here with this part.